let's understand tension in a string. Tension is a stretching force. Suppose this is a body or this is a rod. In this rod, we can have tension also and we can create compression also. Suppose we push it like this, then obviously it is under compression. And when we pull it like this, then a tension is created within the string or within the body. Because of obvious reasons, in a string we can have only tension. To understand tension and its direction, let's take a simple example where we have from a fixed support, we have a 1 kg block which is hanging from this fixed support with the help of a string. This is a string and this is an idle string. When we talk about the idle string is which has got mass is equal to 0, which has no mass and it is inextensible. So this is an idle string. So over here we have a mass of 1 kg hanging from a fixed support with the help of a string. We are interested in finding what is the stretching force, what is the tension in this string, and this string is idle. So obviously we shall be using the free body diagram method. The 3 steps which we use all the time is, first is we isolate the body, second is we draw forces which are acting on the body, and third is apply F is equal to ma, where F stands for F resultant, R is for resultant, or net force is one and the same thing. So F is equal to ma. So if we isolate the body over here, that is how we isolate the body. Let's say I draw a red circle onto this body. That is so that our concentration is, our focus is primarily on this body and our attention is not divided to other things, what is happening to this support or so. So now we look only within this red circle. And the second is draw force in the body. This is my free body. Onto this our free body we apply the forces. Let's say for a time being I remove this. Now over here we see that there is a force of 10 Newton, that is mg, which is acting on it. The earth is pulling it down. Earth pulls all the objects towards the center. It has a tendency to pull all the objects towards center with a force equal to mg. We have, for convenience, for the ease of calculation, we are taking g as 10 meter per second square. So weight or the force with which this block is being pulled toward the center or downwards is m into g. Mass is 1 kg, g is 10, so that comes out to be 10 Newton. So with the 10 Newton force, this is being pulled down. When we draw forces, then now we also observe that this block is over here. This is not moving. This is not moving in any direction. And its velocity is not changing in any direction. It means its acceleration is equal to 0, because acceleration is rate of change of velocity. If there is no change of velocity, it means acceleration is equal to 0. If acceleration is equal to 0, then it means that the net force has to be equal to 0. We see that there is a one force 10 Newton acting downwards, and from none of the other places any force is being applied onto it. It means to counteract this force, there has to be one force which should exist within the string, and that has to be in this direction, and that is what we call tension. And this should counteract this force so that acceleration is equal to 0, so that the net force is equal to 0. So that's why tension, it has to be equal to 10 Newton in this direction. String is like a medium which transmits the force. That is, through this string, this block pulls this support in the downward direction with the force. That is, in one string we say that is only one tension. So in this, it also pulls it down with a force equal to 10 Newton. Through this string, this block of 1 kg pulls this support downward with a force of 10 Newton, and through this string, this support pulls it up with a force of 10 Newton. To every action there is equal and opposite reaction, and action and reaction, they are always on two different bodies. Over here we see that is, this is 10 Newton, this is 10 Newton, acceleration is equal to 0. Now let's understand some of the very, very basic points about this tension or stretching force, or about the string. Tension is a stretching force. In one string, there is only one value of tension throughout one string. That is, we are taking it as an idle string. In one string, there is always going to be only one value of tension. In case of rope, there could be a variable tension throughout its length, depending upon whether this is accelerating or not accelerating. Rope has got a mass. Idle string, it has mass is equal to 0. Idle string mass is 0, and this is inextensible. This you should remember. Mass of rope is not equal to 0, and then when suppose the rope is accelerating along with some blocks, etc., then throughout its different cross sections, the tension could vary. Direction of tension is always away from the body. This is very important. That is, whenever you draw the direction of tension, you should be very clear. That is, whenever you isolate the body, especially when there are strings like this, you draw a circle and tension is always away from the body. Tension is always outward. For this body, if you're talking about this body, tension is outward. For this fixed support, tension is outward. In one string, there is one tension only. So tension is a stretching force. Direction is always away from the body. One string, one tension. These are few key points which you should keep in mind always when you are going to solve questions on strings and blocks and pulleys. Now let's do one thing. We put whole this thing in an elevator, and this elevator is suppose going up with 1 meter per second square. This lift is going up, this elevator is going up with the acceleration of 1 meter per second square, and there is a person on the ground who is seeing this whole event happening, and we are interested in finding what is the tension in this string. What is the tension in the string? Our force diagram remains same once again. Our methods, we have to stick to these methods. Very religiously we have to stick to these methods. We shall be less bothered about what is the answer we get, but if our steps they are clear, if our understanding is clear, the answer will automatically be correct. Over here, once again, you draw a circle. Mj is 100 Newton is this way, tension is always away from body this way. This person sees this block when the lift is going up, accelerating up with 1 meter per second square, then obviously this person sees that this block is also moving up with 1 meter per second square acceleration. As a result, then obviously he sees that if suppose acceleration is upwards, then the net force also has to be upwards. It means this force has to be greater than this force. So when we apply F is equal to ma, where F stands for the resultant force or net force, so it is upward forces minus downward forces because the acceleration is upwards. So that's why the net force, it has to be in the upward direction. So what we shall be doing is upward forces minus downward forces. T minus, this is 10 Newton is equal to mass 1 into 1. So T comes out to be 11 Newton. Tension comes out to be 11 Newton. Now let's say we have these two blocks 3 kg and 1 kg connected by two strings. This is one string, this is another string, and this is a fixed supports. We are asked, and obviously these strings, they are idle strings. So if we are to find the value, we shall be going back to we shall be using force diagram or free body diagram method, and we shall be following these 3 steps sequentially, that is one after the other. So first is isolate the body because there is string, and what we can do is, if we are to isolate, then what we do is we just draw a circle. This is a kind of isolation, that is we have isolated this body. So when we are talking about this body, when we are concerned about this body, we shall be looking only within this circle. So this is one body we see, and this is second body we see, 1 kg block. This isolation is done. Of these two bodies, isolation we have done is. Second is draw forces. First is, let's say what are the weights. We go to the weights. Earth says, I am going to pull you down with a force of mg, 3 into g. G is taking into VR as 10 meter per second square. So this is 30 Newton, mg, 3 into 10. So this is 1 into g, that is 10 Newton. This job is done. Now comes, that is these circles, they are cutting diagrammatically, they are cutting the strings over here, here and here. So that's why we have to take tension also into consideration, and tension is always away from body. Direction of tension is always away from body. And one string, one tension. So what we do is, over here, that is we call it as T2. If this is T2, from here to here, this one string. For this free body, T2 is in this direction, away from this body, if we are talking about this. And for this, T1 is in this direction. If you draw free body of this support, then T1 will be in the downward direction. So what we have done is, we have drawn the forces, 30 Newton, T2, tension is always away from the body, this body away from the body. For this body, T2 is away, T1 is away. Tension is always away from body, outwards. Now let's say we look within this circle and we try to find out what is the values of tension T1 and T2. Now we go to the third step, that is apply F is equal to ma. These two blocks, they are stationary, velocity is not changing, acceleration is equal to 0. If acceleration is equal to 0, net force is equal to 0, it means upward forces they equal to downward forces, it means T2 is equal to 30 Newton. Then we come to this and we look only within this circle so that we don't get confused. When we are talking about this, we are thinking about this, we are focusing on this, just focus on this. Now let's focus on 1 kg block. So we'll focus on this 1 kg block. We'll look within this circle only. And the three forces which are associated with this 1 kg block is, one is T1 in the upward direction, 10 Newton, and T2 in the downward direction. Acceleration is equal to 0. So obviously that is net force is equal to 0. When acceleration is equal to 0, F is equal to ma. F is the resultant force. Resultant force has to be equal to 0. Net force has to be equal to 0. So that's why upward forces, that is T1, it has to be equal to downward forces T2 plus 10. We can put the value of T2 over here, that is 30. So this is 30 plus 10 is equal to 40 Newton is the value of tension. Let's take now a case where these two blocks, they are hanging from the roof of an elevator. This elevator, this can move only vertically, up and down. And at this instant, this elevator is accelerating downwards with the acceleration of 2 meters per second square. And we are asked to find the values of T1 and T2. Please understand, that is, isolate the body, it's the same thing. Draw forces, the forces they remain same. And now the only change will be, that is the acceleration, because there is some acceleration, as a result there is going to be some change in the tensions. Now when the lift is accelerating downwards, so it means this block is also accelerating downward with 2 meters per second square. Who is making the equation? We will come to later on, let's say inertial frames and non-inertial frames. Over here our observer is here onto the ground. He sees, that is, this whole lift is going down with the acceleration of 2 meters per second square. This is a glass elevator, this is a glass lift. So he can clearly see these two blocks also going down with the lift with the acceleration of 2 meters per second square. So as a result, the equation for this is, because this is accelerating down, so it means this force is greater than this force. So when we apply F is equal to ma, for this it is going to be 30 minus T2, this is net force, this is net force, is equal to mass of this body only, because right now we are talking about this body only, we are focusing on this free body only, is equal to mass is 3 into 2, acceleration is downwards, so 30 minus 6 is equal to T2, so T2 is equal to 24 Newton. Similarly, if we wish to make an equation for this is, now we shall be focused only on this body and we shall be looking within this circle only. And within this circle we see that these are three forces which are associated with this block of 1 kg. T2 and 10 Newton, they are in the downward direction, and T1 is in the upward direction. Because this is accelerating down 2 meters per second square, this is also accelerating down. This person sees this block also accelerating down. So it means the net force has to be in the direction of net acceleration. Net acceleration downwards, so that's why net forces, they have to be equal to downward. It means that is we have to subtract, that is from the downward forces we have to subtract the upward forces. So downward forces, that is 10 plus T2, this is the downward forces, minus T1 is equal to mass is 1 into acceleration is 2. We can put the value of T2 from here, 24 Newton over here, and we can get the value of T1.